6.13. A raindrop of radius 2 millimeter falls from a height of 500 meter above the ground. It falls with decreasing acceleration due to viscous resistance of the air until at half its original height it attains its maximum terminal speed and moves with uniform speed thereafter. What is the work done by the gravitational force on the drop in the first and second half of its journey? What is the work done by the resistive force in the entire journey if its speed on reaching the ground is 10 meter per second? Now see here, radius of the drop that is given to you 2 millimeter. That is 2 into 10 raised to minus 3 meter. Height from which it is dropped, that is 500 meter. And when it reach the ground, its speed, that is 10 meter per second. Now first of all we have to calculate what is the work done by the gravitational force on the drop in first and second half of the journey. So work done by gravitational force during each half. So suppose it is at height h, then at halfway we can say the distance covered, that is h by 2. Gravitational force, that is mg. So work done by gravitational force, that is equal to mgh by 2. Now mass that we have to calculate here because it is not given to you. See, now mass, that is volume into density. Volume, that is 4 by 3 pi r cube into density. So 4 by 3, 3.14. Radius given to you 2 into 10 raised to minus 3. Take cube of it. And density of water, that is 10 raised to 3. Okay. Now calculate this particular mass. Then after substitute the value of mass here. Take G, that is 10, h by 2. H is 500, so h by 2, that is 250. Then solve it. You will get work done by gravitational force during each half. Now, second question, that is, what is the work done by resistive force? And in that, the speed is given to you when it reaches the bottom, or we can say at the ground. So, as per work energy theorem, the total work done, that is the gain in kinetic energy. So total work done. So work done by gravitational force in one half plus work done by gravitational force in second half plus work done by resistive force, that is the total work done, and that is equal to half mv square. So we can write 2wg plus wr, that is half mv square. Then 2 wg that we calculated here, substitute that value in this bracket, plus wr equal to half. Mass is calculated here, substitute the value of mass. Speed, that is given to you 10, so 10 square. So substituting the values of wg, m and v, then solve that equation and calculate wr. That is nothing but the work done by resistive force. Clear to all of you?